thanks everyone. We're going to, for your patience. So this week we wanted to talk about rapid qualitative risk assessment, SARS-CoV2 in animals, which started as a collaborative venture back in late March of 2020. So next slide, please, Sharon. So we're going to go through the why and when to use rapid qualitative risk assessment, and then we'll walk you through the process that we take to conduct the assessment, and then we're going to go through the results, just the key risk messages that were found from each one, and then go on to the current status and next steps. So next slide, please, Sharon. So this was a new process for us, and we had been wanting to pilot a process for rapid risk assessment, which combined the One Health community aspect of CZ, as well as experience in risk assessment, of course, from Sharon's end. And SARS-CoV2 has provided a lot of opportunities, but as soon as those first reports started in pet cats and dogs, we were certainly able to jump on that and start to look at it. So next slide, please.
So I wanted to talk just a little bit about why and when we'd use this sort of process, because it's not our usual risk assessment process. So this is something we'd use when we have an emerging disease, when we have specific risk questions, a short timeline, and a high level of uncertainty. So essentially, decisions have to be made, and they have to be made quickly. And really what we want to do is provide some risk-based thinking while also acknowledging that there just isn't time or data for a full risk assessment. So the methodology uses 4 principles for dealing with uncertainty. The first being that we use many minds. So there's an expert group, and not only do they bring together just all of their knowledge and experience rather than one person having to continuously try to reach out and get this information, but essentially it leads to better educated guesses. The second being that we clearly state the uncertainty, the variability, and the assumptions, including the context and the sources of uncertainty and variability. The third being that we look at this just from a qualitative perspective, and the reason being that we're just trying to avoid it seeming more precise than it is. And then fourth, and maybe most important, is that this is an iterative process. So we're trying to, rather than having the emphasis on a single final product, the important part is really the ongoing process.
So this is a diagram of that process, and we're not going to go through everything on this slide, but we are going to walk you through each of these steps. And the important thing to just recognize in here again is that iterative process. So next slide, please, Sharon. So our first step is to form that expert group, and there's really 3 key components to the expert group. The facilitator manages the group, the membership, leads the discussions, takes the polls, writes the notes, and deals with any confidentiality agreements if they're needed. The lead risk assessor gathers the scientific knowledge, teaches risk assessment principles, because our experts aren't necessarily experts in risk assessment. The lead risk assessor drafts the risk questions and the scenario trees, votes in the polls, and basically holds the pen on the rapid qualitative risk assessment process. And the experts are experts in their field, but they're not necessarily risk assessors. But they're there, they discuss the state of knowledge and the information gaps. They guide whether we even need a risk assessment to highlight those needs. They vote in the polls, provide their expertise, review the documents and ensure that we heard things correctly. And they're also very involved in risk communication. It is really a collective effort in these situations of very high uncertainty to have the expertise from various locations. So next slide, please, Sharon. So this is the list of our expert group, and this is for all 3 types of assessment: companion animals, livestock, and mink. The group got bigger as we went along. We ended up with 44 people by the time the end of the mink risk assessment occurred. And this is just to show you the diversity and the size of that group. We had animal health, public health, environmental health, and a great array of diverse abilities, opinions, expertise. It was a really excellent group. So next slide, please. So the group then meets and discusses the state of knowledge. And we're looking at the pathogen, the host, and the systems. And really we had to bring in, on, for example, on the mink evaluation, we didn't have any depth of expertise in our original groups on mink. So we brought in private vets that worked directly with the industry to help us really understand it. And they were incredibly generous with their knowledge and their time. We have those initial discussions in that that first discussion meeting, and it can be helpful to have materials prepared ahead of time if possible. So whether it's a CZ report or a ping or work from other groups. So the Public Health Agency's One Health Working Group guidance group was developing guidance for veterinarians at the same time. Many of the members were the same, and so that really helped in the foundation for the risk assessments, having that already underway. This meeting serves as updates in the iterations of the subsequent meetings. So next slide, please. So then we're going to have to determine the need for risk assessment and the scope. Is that risk assessment actually needed to inform decisions? And given the current state of knowledge, can anything useful be provided by that rapid qualitative risk assessment? We had to stop ourselves going down rabbit holes a few times because it's interesting. But then we had to step back and say, okay, will decisions be guided by this risk assessment? It can get really big really fast. And so when we're determining the scope, we're looking at what are the pathways of transmission? Who's the transmitting population? In every case, we started with humans because it's a human pandemic. And then the level of granularity, for example, with companion animals, we started with companion animals, but we ended up with dogs, cats, ferrets, and caged pets because as the information became available, we knew those things were different. And then looking at the populations at risk, who are we actually concerned about? So with mink, we had to look at general public versus veterinarians and staff members who might handle animals versus those staff members that take part in pelting activities, which would have intense contact with those animals. So the membership will be adjusted based on the scope and based on the specific needs, expertise needs. We re-examine the need and the scope at every iteration, and when it's no longer needed, the group is disbanded. So next slide, please. So this is just the examples of what we did. First, we did an evaluation of SARS-CoV2 in companion animals and focused on public health, and just recently have started to look at the animal health risks. That's in progress. And then second, we looked at livestock, pigs, poultry, and cattle. We did a little on horses as well. We focused on public health risk as well as animal health risk. And then we went into mink and it got more complex, and we looked at public health, animal health, and ecosystem risk. So next slide, please, Sharon. The next step after that discussion is to draft the risk questions and scenario trees, and those are drafted by the lead risk assessor based on that expert group discussion. And so the lead risk assessor creates those detailed, very precise questions using risk terminology and draws out those scenario trees to look at the transmission pathways and identify where we actually need to estimate the probabilities. And those will both get adjusted in the next iterations as needed. And we'll show you a little bit of that in the next slide. Is just an example of the graphic facilitation process that was used for part of this event, and not for all of it, because graphic facilitation actually requires quite a bit of preparation, but just as an example. So the lead risk assessor proposes the risk questions, and then they're defined with the group. They're clarified to ensure that everybody understands exactly what that question means. And the group then decides which questions will be addressed, and as well as identifying any new questions that might have come about. So just as an example, in question 1 up in the left corner there, we asked about the probability and impact on mink of the transfer of SARS-CoV2 from humans to farmed mink. And we also talked about how the probability impact had to be separate. And part of that was at the time, back when this started, we didn't have any. We had low prevalence of human disease in the areas where mink were being farmed, and we didn't have any positive cases. So the probability at the time was actually very low, but the impact on the industry, should that happen, we thought might have been greater. We also decided that we needed to have an additional pathway where mink could spread the virus to farm cats and then to other mink or to humans. And that was out of the Netherlands situation that was happening at the time back in May. And so these questions and discussions really became more complex as time went on. Mink were probably the most complex. And the scenario trees became more complex as we moved from companion animals to livestock to mink. So over to you, Sharon.
So drawing out the scenario trees is a really important part of the methodology. And this is just an example. It illustrates the pathways that you're looking at. So here, the vertical part shows the transmission from an infected human to livestock by direct or indirect means. And then the horizontal part talks about the transmission pathway from infected livestock to other humans. And in this one, we included also the probability of infectious virus in meat or tissues, which then linked to food safety assessments that were being done by other people. And one of the reasons it's so important to do this is it really makes you think of all of the steps that are needed for the risk to be realized. So, for example, it's very interesting to see all the studies on susceptibility of different species, but it's important not only whether the animal can be infected, but also can they shed enough and have enough contact with susceptible people or animals to pass that infection on. Then after we do the questions and the scenario trees, we move into collectively estimating. So for this, we use a very crude Delphi type approach, which essentially is just to estimate and then talk and then estimate again. So we did polls of the experts, not only for what they thought the estimates would be, but and this is estimates for likelihood and impact, but also their uncertainty associated with that estimate and comments. Why are they estimating a certain way? Then we come together and we have a facilitated discussion where we talk about the results of the first poll, and we ask people to justify any differences or outliers. And in some cases, maybe somebody was missing a crucial piece of information, or in other cases, maybe they're the only person that had that piece of information, and once they let everybody else know, then they might want to change their votes. So then we give people the option then to go back and change their votes afterwards. This is just an example of how, for the probability and the uncertainty, we're using these qualitative estimates. And then for each probability that you identify in your scenario tree gets a row in this giant table. So it's actually, it's not necessarily a short risk assessment. It's more, the point is more to be fast, not necessarily short. So for each row here, we have the probability, and then we talk about the different points to consider in assessing that probability. And those come from the discussion and from the comments that people leave in the polls. And then we give the probability and the uncertainty in terms of the mode and the minimum and the maximum. Then the lead risk assessor pulls this all together into the document, and the expert group then reviews the document. And at that point, we consider the iteration to be complete. So we're not going through any individual organization's approval processes. And as a result, we have a fairly large disclaimer in there saying, amongst other things, that it doesn't necessarily represent the views of the individual organizations.
So then we move on to risk communication, and risk communication really happens all the way through this process, and multiple stakeholders are involved in the discussion. So we had a good representation of federal and provincial governments. We had some academia, we had the Canadian Vet Medical Association, CZ members. And so that discussion in itself forms an important part of the risk communications. The full written rapid qualitative risk assessment is shared with the expert group. And so remember that what Sharon said, that's rapid, it's not short. And it's rapid in comparison to the normal risk assessment process, but it's definitely not short. And I think our MINC risk assessment was well over 50 pages by the time all was said and done. And so then we create a summary document, and that is shared with the professional community. So the chief veterinary officers, wildlife directors have received it, CVMA and CZ have distributed that to members. One of the things we must be very clear about, we always want people asking for the final version, but we have to be clear, things are changing fast and it's iterative. And that's something I think the uncertainty is something that people can get uncomfortable with, but we have to be really clear, it's going to change. And so get used to that. It's a change in the way we work. We might have to have additional risk communications materials. You know, we discuss it with the expert group internally. For Sharon and I, we may have to talk to our CFIA management or public affairs and figure out what else is needed. It may be incorporated into the guidance document, and so with the Public Health Agency Working Group, that was referred to and incorporated into the guidance document, and it can support media lines and questions and answers. So next slide, please, Sharon. So then wash, rinse, and repeat. We just have to have a regular meeting schedule, and we can start with every 2 weeks, but it depends on the situation. How fast are things changing? Is there new research? Are there related working groups? And again, since the guidance working group had many of the same folks on it at the same time, we didn't have to have it quite as frequently in this case. And when we do those repeats, the expert group meets to discuss the state of knowledge, and then we'll come up with a decision on, is a new iteration required? And if no updates are needed, we can just continue in the rounds as more information becomes available, or we can disband. So next slide, please, Sharon. So we'll move into the results, and it's really difficult to take the results of a risk assessment out of the context of the entire risk assessment. So these have been circulated to the community, the summary documents, and they're available on the CAS website. So what we'll do now is just to go through those key risk messages in each of the assessments. So over to you, Sharon.
So for the companion animal assessment, like we said, we just started out with looking at the public health risk. So we're looking at the transmission pathway from an infected human to their pet and then to another human, and the impact on public health. And we divided this up into cats, dogs, ferrets, and caged pets. One of the most important risk messages was that the likelihood of being infected by another person is notably higher than any likelihood of being infected by a pet. There's also a fair bit of uncertainty and variability associated with the risk of SARS-CoV-2 in pets, but some of the key messages that arose were that the highest risk among pet species is likely associated with cats. That ferrets and some other caged pets, although they're likely susceptible to infection, some of them only with experimental studies, but the amount of contact that they have with people other than their owner is usually very limited. Dogs have a lot of contact with other people usually, but they seem to be less susceptible than cats and even less likely to shed enough virus to pass the infection on. Of course, risk factors were identified, such as people who have contact with many pets that aren't their own, like vets, and also pets that have contact with many people who aren't their own, for example, outdoor cats. And of course, people who are highly vulnerable to disease, such as the elderly. In terms of consequences, we're looking at this given the current context of the global pandemic, with a vast number of cases resulting from exposure to sources other than mammalian pets. So the overall national scale impact was considered to be negligible to low.
So with livestock, there were 3 key areas we were looking at. It was so that the probability of exposure of animals, the animal health impacts in pigs, poultry, and cattle. We did look at horses as well originally, so that was by direct or indirect contact. And then when we went on to public health, it was the transmission pathway from the infected human to the livestock, and then the livestock being able to transfer that to a human other than the one that infected them in the first place. And we were looking at the impacts again in the context of the global pandemic for the public health effects. When it came to food safety, we weren't doing the food safety risk assessments. We were asked a very specific question about the presence of virus in the edible tissues of the animal at the beginning of processing, and those results then fed into the food safety risk assessment. So if you want to, next slide, please, Sharon. So for the animal health impacts, there's now been enough research showing that poultry are not susceptible to infection with SARS-CoV-2, including from our lab in Winnipeg, that the risk was considered negligible with low uncertainty. When it came to the other species, it was very low, and there's been some research conducted in cattle and pigs that show either a lack of susceptibility or poor replication of the virus in these species. In addition, despite the vast number of human cases around the world, there have been no reports of natural infections in pigs, ruminants, or horses. So as a result, the likelihood of infection of these species was generally considered to be very low, with little variation. And then in terms of consequence, even if a pig, ruminant, or horse appeared to be or happened to become infected, just perhaps due to very close contact with a symptomatic person, the evidence suggests that there would be very likely very little spread of the virus between animals and minimal clinical signs. And so the research just has been showing that it doesn't spread between animals even if there is a mild level of infection. So next slide, please, Sharon. So when we looked at the public health risks and the likelihood of human exposure, again for poultry, since they're not susceptible, the likelihood of them exposing people was considered to be negligible. And even if the pig, ruminant, or horse had become infected, there's minimal shedding, a lack of transmission. So a lack of natural cases. This was not going to get passed on to humans. And then the consequence, again, as with companion animals, in the context of the current pandemic, the consequence is negligible to low. This is really a human disease. So the thought of this coming from animals to humans in this context is really very low. So next slide, please, Sharon. So in terms of the edible tissues, again, with poultry, they're not susceptible. So it's negligible risk. And the experiments conducted in pigs and cattle so far have shown that even when there's a low level of viral replication in the animal, the virus was not found in the edible tissues. And in all species, the virus appears to have a predilection for respiratory and GI tracts, primarily respiratory. So for the likelihood of the virus presence in edible tissues is negligible to very low. And again, this was not meant to be a food safety assessment, but rather to inform the food safety assessments as one of many components. And we did not address issues such as downstream cross-contamination of food by infected humans. That was covered on the food safety assessments. So over to you, Sharon.
Mink. So, as Andrea mentioned, the mink assessment was a fairly complicated set of pathways. So we looked at transmission from an infected human to mink and the potential impacts on mink in the mink industry. As well, we looked at transmission from mink to humans, and we looked at the 3 different categories of humans. So those involved with pelting, employees or vets on the farm, as well as the general public. And then we were looking at transmission from infected mink to wildlife, and then also the role of feral and farm cats. The likelihood of an outbreak of SARS-CoV2 on a Canadian mink farm, and this was done before we actually had one, but there was a lot of variation, and it varied significantly by time, by region, farm practices. And really one of the main risk factors is the SARS-CoV2 disease dynamics in humans in a given area. And more recently, we've been collaborating with PHAC on a geospatial analysis that's looking at the locations of mink farms and overlaying that with the human case incidence over time. There's other risk factors such as the stage of the production cycle. The amount of contact between humans and mink varies a lot over the year, and also the level of biosecurity that's implemented. In terms of consequence, the infection can result, in terms of direct effects, can result in either high mortality rates or subclinical infection. So it varies quite a bit, but there's also indirect effects, such as just the cost of control measures, labor issues, and definitely public perception. So it was determined that the overall national scale impact on mink and the mink industry was moderate to high. From a public health perspective, the likelihood of exposure of the general public from an infected farm was considered negligible. But for a farm employee, veterinarian, or pelting contractor on an infected farm, it was considered moderate. There was still some variability there due to the same types of risk factors like the stage of the production cycle and how much contact there is between humans and the mink, but also the amount of PPE that they're using, for example. In terms of consequence, based on when this was done, we decided to look at the current virus situation. We didn't look at the risks associated with mutations at that time. And so, like the companion animal and livestock assessment, the risk was considered to be negligible to low within that current context. Since then, and since there were mutations of concern arising in Europe, that risk has been assessed by public health agencies. And I think it's just the important message is that it's important to monitor for mutations. From an ecosystem health perspective, the likelihood of exposure and infection of wildlife also varied significantly by the region and the farm practices. Wild mustelids and wild felids are most likely to be susceptible, but they tend to be solitary and territorial. Direct contact between them and other animals is likely infrequent, except for escaped mink and wild mink under certain circumstances, like interbreeding or bait stations. Mink farms generally have a perimeter fence and traps within the compounds that are meant to keep wildlife out and prevent mink from escaping. But we did find that these measures are not necessarily consistent across the country. Transmission by indirect contact would be most likely on or near the farm due to wildlife contact with improperly managed manure or compost piles. And this is actually what was seen with the positive wild mink in the US. If infection does occur in a wild animal, the spread of infection is considered to be most likely limited and transient. And this is because wild mustelids would be most likely to be exposed and susceptible. But like I said, they have a solitary and territorial nature, which would make widespread transmission amongst them unlikely. In addition, the virus transmits best in enclosed conditions, and also infections in many animals have so far resulted in shedding of infectious virus of short duration. Of course, there's a high level of uncertainty associated with this, especially regarding wildlife. In terms of farm and feral cats, the likelihood that a farm or feral cat would get infected from mink and then transmit the virus to other animals or people was generally considered very low. Direct contact between these animals and humans and other animals is minimal. They also would be unlikely to contaminate the environment with a high dose and sufficient dose to result in effective transmission. They're not really playing a major role, as far as we can tell so far, in transmission amongst humans or even amongst mink farms. Of course, risk factors could exist. For example, mink to cat to mink transmission on an infected farm. So if you had cats right there on an infected farm, or if you have feral cat colonies very close to an infected farm. In terms of current status, we've basically moved beyond the rapid risk assessments at this point. We're just finishing up that third iteration of the companion animal one. But we've basically moved on to other types of assessment. So, for example, the geospatial analysis that I mentioned with PHAC, regional assessments are being done in certain areas. And also we've provided some scientific responses to scientific questions, for example, related to composting to help out with the outbreaks in BC. I'll pass it over to you, Andrea.
Okay, thanks. So we did do a hot wash to evaluate the process, and that's really for those of you that haven't participated in a hot wash, it's just government speak for what did we do well, what did we do badly, and what can we do better. So we got very positive feedback, and we had real interest in building capacity to use this methodology, and 70% of the folks that participated in that hot wash said they would like to learn this, how to conduct these risk assessments. So we did have some lessons learned. The facilitation is important. It's actually a really big job to coordinate, and it's really useful to separate the tasks from those of the lead risk assessor. So the lead risk assessor can really focus on the science. It's really important for us to supplement those polls with comments and discussion and be able to follow up with people, because those comments give us the variability, and they tell us where things are different. And especially when you're working at a national level, there will be variability based on region, based on practices. And so those were really important. The discussion definitely functioned as risk communication, and it really did help to have a national group that was able to help communicate the risk messages across the country. We did find that zoonotic expertise is one person deep in, particularly in our provinces, where the risk manager is also the risk assessor. So they're doing the same job, and which is a plus and a minus at the same time. It's a workload issue for sure for that person, and so, but the experience and having the full knowledge of the risk assessment helps with those risk management decisions very well. We do need a steering committee, and in this way, the Public Health One Health Working Group acted as a steering committee to function and say, yes, we actually need this to develop the guidance. And then the last one that we sort of lessons learned was timely language translation was a challenge with very long technical documents. It is hard not only to get those translated in a timely way, but to make sure that they are actually correctly translated. So next slide, please, Sharon. So our next steps really are to move forward with this and to make sure we align what we do with a tripartite joint risk assessment, risk analysis operational tool, and that came out in December from the WHO, FAO, and OIE. We would like to develop a manual and to have training on the methodology within Canada, and we'd like to continue to use it when needed. And so what we'll do now is I'm going to stop the recording and we'll go on to the discussion. And